last time that we talked, what we tried to do was my bad, I was looking at something. Last time we talked, what we tried to do was to make sure that the first GET request was sending correctly. Right now, we would not worry about that right now, because now we need to work on the file system like mentioned before. And to make this file system run as it's supposed to, we'll create a different file headings and so on and so forth. 1 second. This is another thing. Just ignore that. So we'll create different file headings. So thankfully, we are using TypeScript, which will make everything way more easier to use and test out. But since we're using TypeScript, we can then use stuff like interfaces and whatnot. This is why I wanted to use TypeScript to begin with, because if I didn't use TypeScript, I would have done the project in Java, because Java will allow me to use it. Because Java is what you want to use if you're building systems. Well, that's what I would rather use if I'm building systems like this. So the first thing we would need to do is create a node interface. So first, let's create a folder we'll call this folder nodes. This is where we'll keep nodes, is where everything will be implemented, and then everything else like the files and the folders will then be extended from this interface. So first we create a folder called nodes, and in that folder we will create a first file called NodeInterface.ts. And in this file, what we want to do is first we want to create the export interface, and we will call this node interface. Actually, we are going to call this export default interface. So let's call this export default interface, because this is the only thing we're importing, so we're just going to call it default. And in this node interface, we're going to have does TypeScript have an enum? No, it does not. So since TypeScript does not have an enum, what we're going to do instead would be since TypeScript does not have an enum, what we're going to do instead is create a sort of enum, like Java has an enum, so we're going to create a sort of enum representative. So we'll call this enum node type, because remember, we're going to have a folder, a file, and then a line. Those are the different types. And in this public, we'll call it public type node type. And in this, we're going to say it can either be called a file, either be called a node, or either be called a folder, a file, a node, or a file, a node. I'm trying to think out loud, my bad. A file, a load, or a line. Public is not here. So let's see. That's going to give us an error. Okay. So what we're going to do is we are going to say export this type, node type, and this node type would be like I said, a file, a node, and so on and so forth. So and then we're just going to delete this as well. Okay, so right here we then want to say we want the node interface to be able to tell us what type of node class it is. So we'll create a function called gets node type, and then this will just be and it will tell TypeScript that this should be returning node type, right? And then we need another function called get content, and then this get content should return a string, because we're getting the content of the file or the line. And then we want to know the node ID, because every file has an ID that located to it. So we're going to say So we want to be able to get the node ID, but then we also want to generate the node ID. So we would want to say generates node ID, node ID, and then we'll give it a, my bad. And then we would say generate node ID would be, it will be a function, and then it should generate a string. And then we want to do that same thing for generate gets node ID, which should just give us a string to return. Let me see if I can do that same thing for, let me see, type nodes. So it wouldn't let me do type here. Type would be either file, node line. Will that work? Will this work? Okay, we're going to leave this here in case it doesn't work, but if it does work, we're, you know, it works, right? Okay, so yeah, we're going to leave that there. Then we need to say, then we need to be able to set node ID for a new file or whatever, or so we'll do the set node ID, and the set node ID will take a string and it will return void. So let's take that string node ID. What is the error? Oh, I'm tripping. Node ID, and then, because I'm thinking in the form of Java. So node ID string, so, and it returns void, then we would need to say add child. So think of it like, you have a file folder, and then you want to add a file to it, and then you have a file, and you want to add a line to it. So we need to be able to allow it to add a line or a child, and so on and so forth. Allow it to implement itself. So to do that, we would then say add child, and then we would say child, and then this would just be a node interface. Node interface, and then this add child variable function, excuse me, this add child function should be void as well, because we are not expecting any return value. Then we want to say remove child, give it permission to remove child in case of anything, and it should be void. And then we want to say then we need to think if we want to give it permission to remove a child based on the string, like based on the ID of the child, because remember we're saving children based on ID. So do we want to be able to remove children based on that? So let's do that. Remove child. I don't know if TypeScript will allow me to do this, but I'm gonna say child ID equals to string. Oh, it allowed me to do that. No, it did not. Void. It did not allow me to do that. So since we cannot do that, we will say this or string. So we're expecting this or string. So in case we get a string, we'll do some type checking. So in case it's a string, we'll do run a function instead. In case it's not a string, we'll run another function. Alright, so next we need to check if, next we need to have another function to print out that, have a custom print function, right? So we need one function that we need to be able to print. Remember, this function will print void. We will return a void because it's printing to the console and it's not actually returning a statement. And in this function, print as child means that what we wanted to do is that we wanted to loop to a certain level. What we wanted to do is that we wanted to loop to a certain level. Let me see if I can explain it. So So this is this right here is the base level. Let's say this is a folder. This brackets indicates a folder. So we have another folder. We call this folder 1. And then this folder 1 has its own children. Right? And then this has a name. And then this will be a file. And this file will have line 1, hello, line 2, world. Right? It's going to return an error, but we're going to delete that later. And then line 2 will be world. So this indicates the file system. So if we want to say print level 1, this would be level 0, and then this would be level 1. So what it will end up printing is everything in this level 1 space, which includes name, and if anything's under name as well. Now if we say print level 0, it will only print folder 1. It will only print the levels in this folder, and then the children of that levels. You see what I'm saying? Right? And so let's delete this. Okay. So then print as child, and then we want to have a custom toString method. So we will just say toString, and then this will just return a string file. Alright, then we just need to add types. We just need to add comments, so we can use for later. The type of node. Then we need to say get node type. We just need to tell it the type of node this is, because node type will be private for each node, and we don't want to directly get it, so we just need to use a function to do that. And then get content, we need to say get content of line and file node. We don't want it to do get content of folder, because we want the folder to return an object, but we want the file to return string value, because every line we can just put /n to indicate a new line, but we can't do that for a folder, so that's why we want to do it like that. So get contents, this method, and we're just going to give ourselves a note. So let's put a note right here. This method should only be implemented by a file and line node, and then close parentheses. So we're going to say that. Alright, good. Okay, so then we need to do generate node ID. So this generate node ID, we want to say generates a random ID and returns it. Well, clearly we know it returns it. Okay. And then we want to do get node ID, returns the node ID, and then we want to set the node ID. So sets the node ID. So some of these functions are pretty self-explanatory, because we have a good variable or /function naming system. So, and then add child, we want to say add a child to the node. And then remove child would say removes a child from the node. And then a little note uses either the child itself or the ID of the child. So a little note for ourselves for later use. And then we just need to have a print statement, and then we'll just say print out the node and all of its children. And then for the print as child, this toString is a custom method for all objects, so we don't have to really implement that for real. But we would say this prints off the node and all of its children in the sense that this node is a child of another node. Only a node type should implement this method. Let's put that in code sign. Should implement this method. Alright, and then okay, so since we have that, the next thing we need to go into is the actual node. So we had the node interface, so now we need the actual node to be able to implement this. So now we're just gonna create a node file. So we're just gonna call this node.ts. So the node.ts would import node interface, and then it says node.t. Beautiful. Okay, and then now we need to export this default node that implements node interface. So to do that, we say export default class node implements node interface, and then this is going to return an error because we are not implementing the functions that we asked it to implement. So this node ID needs to be, and then this should be. Okay, so I changed a few things because I noticed that this was returning an error. So the first thing I changed was I created an enum, right? So you can tell it that node type should be an enum of node types. So then we can just put this that node types dots, and then we'll give it an enum of node. So that should fix that error. So now we then need to implement the rest of these classes. So to do that, we will just change this into change all occurrences. So we didn't change this equal to equal sign, and then that should fix most of it. And then just a quick editing stuff. So the next thing that we need to work on is actually giving this the return type it should be getting. So first, let's do something like this. Tell it that you're getting a return type of that, so then we can then do this, right? So because we told you that it's getting a node type return type, it's getting a node, is going to return a node type return type, and when I return that, it would return an error. So to fix that situation, we would just simply say return this dot node type, right? And then since we've done that, the next thing we need to do would be to then we have the get content. Remember, get content should not be implemented by Get content should not be implemented by Node because it was in the comments. Get contents of the line and file node only should be implemented by file and line node. So now we need to get node ID. So we can just say this and then put a bracket right here. Okay, so for this bracket, we said that it's going to return a string, but it's not returning the string. So that means that we need to have a variable called. Let's create the variable, and then this will be a private variable. So we'll give it a private hashtag to tell it it's a private variable. So we'll call this node ID, and then we'll say it's a string, and then in the constructor we will have an empty one. We'll have an empty one just in case is not provided. Okay, actually let's create a interface right now and then call it interface node params, and then this parameter we'll just say node ID, and then we will have a question mark there telling it in case if it is not implemented, and then we will say string, and then we will give that no params, and it will say if param dots, let's put this in brackets, if parameters dots node ID, then we need to do this hashtag node ID equals to parameter node ID. Else we just need to use our generator and say this dot hashtag node ID equals to get generates node ID. Yes sir. And then we'll say this dot generate node ID, this dot generate node ID. Right? If it's not generated, we need to generate it. If it is generated, right? And then for now we'll just leave this blank, and then what we then need to do is this, since we're returning the generated node ID, we then just need to return it right here. Return this dots node ID, and then right here we're setting the node ID. So since we're setting it, all we do is we just set it, so we would just say this dot hashtag node ID equals to right, and then for now we'll just leave this as blank. We'll implement it later, but for now we just leave it as that. Okay, so now we need to work on generating this node ID. To make things easier on the outside, because I don't want to do that much, we will just simply install a library called GUID, so that way we can use to generate UID. So once we're imported it, the next thing we need to do is say const v4 and call it UUID v4, and then equals to require UUID. Oh my god. Okay. So oh my bad, let's do import from and then let's just copy and paste this. While this is waiting, I'll put an S right there. So, and then right here, we just want to say, let's new ID, my bad. computer just got slow all of a sudden. So now we just want to say, oh my goodness. We want to say let's new ID equals to dots, and then we just want to UUID. I think there should be a way to just quickly generate it, unless I'm tripping. Oh, you can just call it, my bad. So this will generate the new ID. Then what we want to do is then we want to check if that generated ID has already been created. But before we check if the generated ID has already been created, we need to create, drum roll please, we need to create a variable called, a private variable called children. And then this children should be an object. It should be an object, and the object would be, it would be a dictionary object with the key string and the node interface. Okay, so and then we'll set it to this. So first we generate the ID, and then what we want to say is if we want to check if the object is already included in the children. So if objects dot keys dot this dot hashtag children dot includes new ID. If it includes a new ID, then we want to return this dot generate node ID. We want to return that. If it doesn't, else we just want to return the new ID. It's that simple. Return new ID. Okay. So yeah, it's not really that complicated for this main part. I know the video is running a little long, but I'll try to finish it up this. Then we want to implement a method that allows us to add a new child. And to do that, we had the child as a node interface, so we want to check if child that gets node ID equals to node types that's oh, I'm tripping. I'm trying to think about something. So this, we get the node ID, so we want to see if the node ID is empty. If it is, what we then want to do is we just want to say child that sets node ID equals to this that generates generate node ID. And then we want to see if child that gets node ID is null, as in there's no node ID at all, like it wasn't implemented. Then we want to return, actually I can put it all in one if statement rather than put in multiple statements now. Yeah, it's either an empty string or it's null. Then we want to return the child that said node ID. And then this last statement would be, then we want to check if the node ID is already in. So let's do children, this dot hashtag children dot no object dot keys. I'm tripping. Object dot keys dot this dot hashtag children includes child that gets node ID. If it includes it, that means we have to generate a new node ID. So we say child that sets node ID equals to this dot generates node ID. So since we have run that, then we can finally put it into this dot children dot child that gets node ID, and then we will make that equals to child. And then we can go on to our next function, which would be to remove the child. Okay, so this remove child is going to be a little more complicated because sadly JavaScript doesn't allow us to implement override a function with either string or blah blah blah. So first we're going to say if type of child equals string. If type of child is string, else if type of child equals to it would have a node type if it was from a node interface. It would have a node type, so we can use that to check that out. So we can say if node type plus node type is not silent, else if child, I just figured out a better way to do it. So we want to say if child is instance of string, then we want to run a certain function. If child is instance of string, then we want to run this function. If child is instance of NodeInterface, then we want to run this function. Well, then again, TypeScript wouldn't really allow anybody else to put any other different type of types. So, let's see if I put, would TypeScript allow me to make this a type rather than an interface? It will return an error, so let me make this an interface. Alright, so right here, I'm just going to say if child dot gets node ID, get node type. Is it node type? You know what? That will return an error too. So forget it. We're just gonna be under the assumption that TypeScript would not allow people to input any other different type of types. Anyways, we go back to this. So if it's a node interface, all we really have to do is say you know what, actually let's only allow string to make this less complicated. a string. Yeah, we are only going to allow string, so let's make this less complicated. So then we would just say this dot children, and then we would say child, and then we would just say delete. So we're just deleting that children or whatever. Then we are going to go to the toString function. And this toString is, I know you guys are asking, why are you going to implement this toString first? But that's a good question. Because the other functions might use the toString, so it's better that we just do this first. So first things first, we will need a print statement. So it's print statement equals to, oh, I didn't initialize it, so let's print statements, and then we will say int, I'm still thinking in, let I equals to 0, I stands for index, and then we say for key in children in objects dot keys dot this dot children, and we say let's key of object dot keys. It will return a string because if we say in, it should return a. How are you gonna return an integer? I don't know, bro. Yeah, let's actually, it might just be a lot easier if we do this. So let's do this instead. Nah. I'm trying to think of it. Okay, so how do we run this? So now that we have this, that we want to add to the print statement, we'll add to the print statement by doing exactly like this. And then we would say, in this print statement, we will have one thing, start off. So we start off with this. So to put a tab, then we will have the key, and then the next thing we will have is this, and then after that we will then have this dot hashtag children dot key dot print as child, and it will give it a level 0. The level 0 being that a level of 0. I'm trying to think. A level of 0 being that this is as base level, you know, like we are not really. There's no child before it, right? There's not. The only parent is the one that's calling it, that type of stuff. And then next thing we would do is that in this statement we would just then do this, because now we want to decide whether or not we want to put a comma. So to decide whether or not we want to put a comma, we would just say object.keys dot this dot children, and then we'll put a dot, and then in this we will then put length. If length -1, right? So then what this is checking is saying that if this is not the last index, what we want to do is we want to add a comma and a new line. However, if it is the last index, we don't want to add anything. As simple as that. So now let's make this more clean and properly. And then after that, we will just implement a new index. My bad. We'll just implement a new index, and then we'll say return print statement plus equals to, and then we will just do slash pop-on. And then now we can then go to print as child. The print as child is basically the same method, but now it takes in a level as an argument, right? It's basically the same method, but it takes a level as an argument. So we'll just copy and paste this. And then we also need a function called getTab indent. This is not really a main function, being that all it's really doing is, because remember when I say the print statements, it's just to make the print statement look pretty. Okay, so now let's get to work. So this is also returning an error because it is not implementing the getTab indent. So to implement this, we will just say, let's say this for now, and then we set this to return a string. And then let this return a string. Oh shoot, we've been recording for an hour. Alright, so I know this video is kind of shoot. Okay, so after this I'll end the video. I'm sorry y'all, I know it's taking about a minute. So print as a integer. So right now, like I mentioned, it's still going to be the same thing. So we start off with a print statement, we start off with the index. So let's just do copy and paste this right here. And then we want to loop through it again. So we say for let's key of object.keys this dots children, right? And then now what we want to do is that we want to add to that print statement, like I mentioned before, the print statements. So with this new print statement being added to, then we want to have now we want to use the getTab indent, because if you think about it like children, right, we want to see how many spaces do we need to farther away. So let me show you an example. So you see this like this, right? So this is the first level. The first level has name, and then it has another level. So this is 2 tabs, because this is, it starts 0 tabs, 2 tabs, and then if we have another level, that's 3 tabs. 4 level, that's 4 tabs. So you see why we need to keep adding new tabs based on the amount of levels we have. So let me just delete this real quick. And then we can then say getTab indent, and then this would just be level plus 1. And then what we need to do here is then we then need to have the key, the key of the ID, whatever. And then we then need to have this, and then we then need to have this that's, I forgot to put this that's children, and then we then need to get the key. And then we then need to say print as child, because then we want to print the child of whatever, and then we'll give it a level, and so it's just going to be level plus 1. So this is a recursive algorithm right here, because every time that we call this print as child, this method is also calling the print as child for the rest of its children. So And then last thing we want to do is then we want to say the same algorithm we wrote down here to see if whether or not we want to add a comma. We just put that there too. And then boom. So next thing we want to do is then we want to implement add this I++, and then we want to have a return statement of this, and then we'll say this. Okay, so it's looking pretty good. I know you guys are thinking, yeah, but all you're writing is code, but you're not really showing exactly what it's going to show. Just give me a second. We're almost there. So for this tab indent, it's going to be a simple looping algorithm. So we're just going to say, let's tab indent equals to empty space for now. Then we will just say for let I equals to -1, because we want to start for -1, I less than level, I++, and for every I we just want to do tab indent plus, tab, and then we want to return that tab indent character, and then that's it. So for the print statement, all this print statement is really doing is calling console.log this.toString. That's all it's doing. So now, drum roll please. Time to test it out. Actually, we're not done testing it, not done making it yet. For now, I will end the video right here. We're going to end the video right here because next video, what we're going to try and work on is try to work on the file node. The file node will be the same implementation, like we need to implement the same classes and functions, but it might be a little bit more fun. Not really, but yeah, it would just be the same implementation as the node, but with a different class name. Because we wanted to do the same thing, but a few things and touches might be different. And after the file node, then we will go into the line node, and then after that, then we'll go into the files. Then we'll separate them into different folders, like a folder file, a files file, a folder, a files folder, and then we put in some exceptions folder. After the exceptions folder, then we can work on the contents of it, like the metadata of each folder and of each file. Then after that, we will then walk in on the file system itself and add all these different components and bring them all together. I'll see you on the next video. Peace out.